Hi there and welcome to Olagold Academy. For today, we're considering a topic which is dimensional analysis. Now let's jot this question down. The velocity V for the streamlined flow of a liquid in a small uniform tube depends upon the radius r of the tube, the density rho, and the coefficient of viscosity eta of the liquid. Full stop. Use the method of dimensional analysis to obtain an expression for the velocity. Given that V equals to r squared times P over 4 eta L, full stop, where P over L equals to pressure gradient. Obtain an expression for dimensionless constants in the expression of V, that is, we are making V the subject of the formula. Alright, without putting more time, let's go into the calculation. Now the first thing to always do is list out the given parameters. And like I said earlier, is either three parameters depend on one, or one parameter depend on the other three. For this question, we check very well. It's saying that the velocity V for the streamlined flow of a liquid in a small uniform tube depends upon the radius, depends upon the density, and depends upon the coefficient of viscosity. Alright, as usual, the first thing to always do is to list out the given parameters. So from the question, we are given velocity V, we're also given radius, we are given radius as r, we're also given density, which is rho. We are given density, which is rho, to be equal to, we're also given coefficient of viscosity, which is eta. We are given viscosity, which is eta. Alright, I think that's all. Yes, that is all. Alright, so the next task is to write their dimension, to obtain their dimension. That's the next task to do. The dimension for velocity is LT raised to power minus 1. Velocity, the dimension for radius is L. Dimension for the next one that we are having, the dimension for density is ML raised to power minus 3, and dimension for viscosity is ML minus 1, ML raised to power minus 1, C raised to power minus 1. Now, I've done a video on how we can dimension physical quantities as this. You can check it out in my YouTube playlist. I've done a video on this. Alright, the next thing is to write out their dependency. And I've said before that we have velocity depending on radius, depending on density, and depending on viscosity. So to write dependency, it becomes velocity is directly proportional. So we use proportionality sign to write dependency. So V is directly proportional to radius, which is radius, to density, which is rho, and viscosity, which is eta. So we have this. Our next step is to introduce constant. So it becomes V equal to K radius eta multiplied by viscosity. So we have this. Our next task is to make this K to be equal to 1. So let K to be equal to 1. So this is our next task here. Alright, so if we have this, we're going to have V to be equal to 1 all multiplied by radius rho and eta. So we have this. Now, if we use 1 to open the brackets, it becomes V equal to radius, rho, and eta. So we have this. Our next task is to introduce what we call superscript. Introduce superscript. So we have introduce superscript. Introduce superscript. That becomes velocity equal to radius x power x. Then we have rho x power y. Then we have eta x power of z. This one becomes our equation asterisk. This becomes our equation asterisk. So our next task is to bring out their various dimension. Bring out their various dimension. So we're going to have this. So we're going to have this. We're going to have this. Our V dimension is LT minus 1. So we have LT minus 1 to be equal to dimension for radius is L, which is kind of length. So we have L. It's having a superscript of x. So we have multiplied by x. Alright. Next we're having density, which is rho. And the dimension for density is ml minus 3. So we have ml minus 3. All raised to power y. So you have y. The next one is eta, which is viscosity. And the dimension for eta is ml raised to power minus 1, c raised to power minus 1. So we have this ml raised to power minus 1 and c raised to power minus 1. So we have this. Everything raised to power of z. Power z here. Alright. Now our next task is to open the bracket. So we have LT to the power minus 1 equal to L to the power x. Then there's a power of invisible 1 here. This 1 times y becomes m is power y. We're having L here, x power minus 3 times y equals n is power minus 3y. So we have this. Next, we are having m here, having the power of 1 times z here. So you have n raised to the power of z here. Alright, our next task is to take n, the power of n, which is minus 1 times z here, becomes minus z. So we have this. Our next task is to take t, taking the power of t, which is minus 1. Minus 1 times z equals t minus z here. Alright, our next task is to rearrange in terms of MLT. Rearrange in terms of MLT. So we have this. So we are going to have LT minus 1 equal to, we are bringing this M together. Remember, we are arranging, this concept is the concept of MLT. So we are going to pick M first, before L and before T. So we pick M first, we have N is power Y, then we have M is power Z here. Remember, all these terms are multiplying each other. They are multiplying. They are multiplying. All right. Our next task is to take L. So we have L raised to power x. Then we have L raised to power minus 3y. Next, we have L raised to power minus z here. Minus z. Like we say minus z. All right. Lastly, we are taking C. So which is we are having C raised to power minus z also. So our next task is to, if we have two bases multiplying each other, in indices, what do? We take their powers. We take their powers. So we have LT minus 1 equal to m raised to power y plus z there. So we add the powers. All right, next to L, we're having L raised to power x plus minus 3y give us minus 3y. So we have x plus minus 3y plus times minus give us minus. So we have this. Next we are having plus minus x z plus minus z give us minus z. So we have this here. We have this. Next we are having c is power minus z. So we have this. We have this here. Alright. Our next task is to compare their powers or compare index. So compare power or index. Compare power or index. Now we are going to take m before L and before T. Alright. So for m at this side, what is the power of m at this side? It is nothing. So write 0. So write 0. So we have 0 equal to power of m at this side is y plus z here. So we have y plus z here. This becomes our equation 1. We have our equation 1. So we have this. Next, we are having L. So for L, at this side, the power of L at this side is 1. So we have 1 to be equal to. At this side, the power of L is x minus 3y minus z. Yes, so we have x minus 3y minus z here. This becomes our equation 2. So we have equation 2. Alright, our next task is to take T. So for T, we have at this side, the power of T at this side is minus 1. So we have minus 1 equal to. At this side, the power of T is minus z here. So we have minus z here. This becomes our equation 3. Equation 3. So we have this. Alright. Our next task now is to get our variables, their values. So from here now, we are going to look at the equation whereby we can quickly get our variable, the value for the variable. If we check these 3 equations, we can see that we can easily get z, the value of z there, from equation 3. So we're going to write from equation 3. So we're going to have this equation 3. We're having minus 1 equal to minus z. So we have this. Our next task, we're looking for z here, not minus z here. So what do? We divide both sides by what? By minus 1. So we're over minus 1 over minus 1. So minus cancel minus, minus cancel minus. So we have 1 equal to z. This implies that our z equal to 1. So we have this. Here. Now we are still looking for y. I'm still looking for x. Alright. So our next task is to put our our z into equation 1 to get y. So we have this. Alright. So our next task is to put this value of z here into equation 1. Equation 1, we're having this. We're having 0 equal to y plus z here. Alright, so let's bring this z to this side. We're going to have 0 minus z equal to y. So we have this. Alright, the value of z is 1. So we have 0 minus 1 equal to y. So having minus 1 equal to y. And this implies that our y equal to minus 1. So we have this. Alright, our next task is to get our value of x. So put y and z into equation 2. Put y, put x and y. Put x and y into equation 2. So we have this. Alright, equation 2, we are having 1 equal to x minus 3y minus z. So we have this. We're looking for 3y. So we're looking for y rather. So we bring all these 3, we bring it to this side here. So we have 1 minus x. This x cross this equal to sign to become negative. Then we are going to have this minus z crossing this sign to become positive. So we have plus z equal to minus 3. We're looking for x rather. We're looking for x. So we are going to have 1. This one becomes plus 3y. So we are having to this side, we are having plus z equal to x. So we have this here. Alright, our next task is to input the values. So we have 1 plus 3. Value of y here is minus 1. Plus z here is 1. So we have 1 equal to x. So let's open the bracket. We are going to have 1 plus 1. So we are going 3 times minus 1. We have minus 3. So we have minus 3 plus 1. We have plus 1 equal to x here. Equal to x. So we have this. Let's not forget our equation as static because we need it. So our equation as static, let's put inside brackets, inside a box. We have b equals to r raised to power x, rho raised to power y, and we are having eta is power of z here. So we have this. Here. Alright. Let's take this one off. Alright, our next task is to calculate this. 1 plus 1, we have 2 minus 3 equal to x. 2 minus 3, we have minus 1 equal to x. So, and this implies that our x equal to minus 1. So we have this here. So this implies that our x equal to minus 1, y equal to minus 1, and z equal to 1. So we're going to put value of x, y, and z into equation asterisk. Alright, so let's put these values here into equation asterisk. So we're having v equal to r raised power x, rho raised power y, and eta raised power of x. Sorry, raised power of z rather. Z there. Power of z. So we have this. Alright. So we are going to have v equal to r. Value of x here is -1. So we have -1. Rho. Value of y here is -1. So we have -1. Eta is having a value of is having the power of z, and value of z is 1. So we have 1. So this becomes v equal to 1 over radius. You're having 1 over rho. Then you're having eta. You're having this. From here, we're going to have our v to be equal to rho over radius. Sorry, eta over radius times rho. So we have this. We have this here. So our next task now is to bring in our k. So we're going to have v equal to k eta over r multiplied by rho. Now I could have stopped here, but the question says that given that v equal to r squared p over 4 eta l. So we have this. We are given that v equal to this. Alright. So we are going to replace value of v with this. So from there, we are going to have our v to be equal to this. So we have r squared p over 4 eta l to be equal to k eta over r times rho. So we have this. So we have this from our question. It says given that v equals to r squared p over 4 eta l, where p over l is pressure gradient. Where p over l is pressure gradient. So we have this. Alright. Our task here, it says obtain an expression for the dimensionless constant. Obtain an expression for the dimensionless constant. Obtain an expression for the dimensionless constant. So it means that in this equation here, we are making k to be the subject of the formula. That is what it means. So alright, what do? We cross multiply. So bring this one here and bring this one here. So we have k multiplied by eta multiplied by 4 multiplied by eta multiplied by a. So we have this equal to r squared times p multiplied by r times rho. So we have this. Our next task is to divide both sides by the coefficients of k, which are this. So it becomes everything over eta multiplied by 4 multiplied by eta multiplied by a. So we have this over rho multiplied by 4 times eta and L. So we have this. We have this. From there, this cancel out this. So we have this. So we're going to have our, let's take this off. Let's take this off. So we're going to have K. So we're going to have K to be equal to, K is not equal to R squared P R multiplied by rho over, you're having eta multiplied by 4 multiplied by eta multiplied by L. So we have this. Alright, if you watch carefully, you can see that R and R are the same. Eta and eta are the same. Alright, so we're going to have our K to be equal to, we're going to have, let's say P, let's take R first. We're going to have R cubed and rho. So then we have P. We have this over eta and eta are the same thing. So we're going to have 4 eta squared times L. Alright, you could stop this way. But the question says that where P over L is pressure gradient. So it's very okay to segment the pressure gradient. It's very okay to segment the pressure gradient out. So we're going to have K to be equal to R cubed rho over 4 eta squared multiplied by P over L. So we have this as our final answer. Where P over L is pressure gradient. So we have this. Alright, this is the part 2 video on dimensional analysis. So I'll be releasing more. Do have to check my videos. I'll be releasing more examples on dimensional analysis. So if you find this video helpful, do have to hit the like button, subscribe if you're not a subscriber, share and follow, and drop a comment if you really understand this, or tell me how you feel about the video. If there's any place where we're going to adjust, we should make adjustments. So thanks for watching. This is Ola Good Academy. Thank you.